Hello there everybody and welcome to this live class number 92 where we are going to be seeing how to generate a map in ROS2. So let's go for it. Let's start. Let's go. Alright, so hello there everybody and welcome to this live class number 92. We are getting really close to the 100th live class, so I hope we are able to do something special there. However, not yet there. We are on live class number 92 and today we are going to keep working on the ROS2 Essentials series. And in particular today we're going to see how to create a map in ROS2. We are going to be using the cartographer package. Yeah. So yeah, welcome everybody. Let me know in the chat if everything is going fine, if audio is fine, video is fine. From what I can see here, everything appears to be okay. But I always like to have a confirmation from you guys so that I can keep going normally. Whoa, cartographer. Whoa, cartographer, says Dinesh. Yeah, cartographer from Google would be an app. It would be. You would not be wrong. Okay, I see many comments here. You have been already chatting here, from what I can see. So let me know, guys. Is everything fine? Can you see me properly? Listen properly as well. Everything is okay, Alberto. Okay, excellent. Hello, ROS Developers. Is there Capute there? Hello there, ROS Developers. In this case, it would be ROS2 Developers, but well, let's say ROS Developers. Yeah, it's more general. Audio and video are working. Says also engineering nations. Okay, excellent. So let's go for it. So as always, I'm going to start by sharing with you guys the project. So I will switch to my computer screen right now, but before that, as always, I want to get here, drink some coffee from my ROS2 fancy cup. As you can see, I have switched these last live classes from the ROS Developers Mac to this ROS2 Mac, which is more appropriate for these live classes. So there we go, we are ready to start. So let me switch to my computer screen right now. Alright, so here I have my ROS Development Studio, here I have my live class, so I'm going to grab here my link and share it with you guys here in the chat. Let's put it right here. Alright, so now as always, remember, with this link, you have to log in into the ROS Development Studio. If you don't have an account, just create it. It's a few seconds and it's free. Then once you are logged in, you can copy paste this URL and you are going to get in your workspace the ROS Developers live class number 92, which is this one here. Yep. Then what I'm going to do right now is to open it, is to start opening this project by clicking here in the Open Project button. And this is going to start loading the whole environment. It might take maybe 1 minute or something like that, since this is a ROS2 project. And meanwhile, what I'm going to do is to, as always, explain and tell you about a couple of things. Well, in this case, I'm going to keep it simple, and I'm going to just talk about the ROS Developers Day, because each day this is getting closer and closer. So let me share with you here the web page. So here we have, let me share it with you as well in the chat so that you can also access it. There we go. So yeah, we have the third ROS Developers conference, which is renamed to ROS Developers Day. since it is going to be held in one single day. Yes, so it's going to be held on June 27, which is getting closer and closer. We are 1 month far, I guess, more or less. Yeah, 1 month and 1 day. So we are almost there. And then this is going to be a complete, a full day with ROS conferences, with many ROS specialists. We are starting to get here, we are starting to reveal more and more speakers, as you can see here. And yeah, it's going to be very similar to these live classes, but they are going to be one after another and talking about many different ROS topics. And in this case, I'm not going to be talking, but the conferences are going to be done by ROS specialists from all around the world. Yes? But it's going to be super interesting. We are going to learn a lot and we are going to be able to practice a lot, because we are going to be doing this in the ROS Development Studio, so that the conference is not to listen somebody talk, but to listen and practice what you are learning at the same time, which is the most interesting thing. And it's the best way, at least we think it's the best way to learn something, by practicing and by doing. Yeah. And also, finally, I want to thank our sponsors, which are Proxima and Robotics, which are supporting us for this ROS Developers Day. So thank you very much, guys. And yeah, so I wanted to talk about this today. So that's all. Let me close this. And hopefully I have my ROSject already loaded here. There we are. So here I have my ROSject. There we go. And with my notebook opened here for the live class number 92, ROS2 Essentials mapping. Yeah, so I want all of you, as always, to be in the same point as I am, here with the ROSject completely loaded and the notebook here opened and ready to start practicing and ready to start mapping in this case. Yep. So let me know, guys, if you are already set up, if you are ready to start, if you are here at the same status as I am. So let me have a quick look here at the chat. Is ROS2 much slower than ROS1? I seem to see some comments about performance issues with it. Well, Tawanda is asking this. Well, you have to bear in mind one thing, Tawanda, is that ROS2 is still under heavy development. Yes? So ROS2 still has to be much more developed. So currently there are some things which are taking much time. For instance, sourcing. Now it's better, but at the beginning sourcing was super slow in ROS2. Now it's getting better, but you all guys have to bear in mind that ROS2 it's still under development. Yeah, so ROS1 has been there for many years. Many people has been working on it, improving, creating packages for ROS1. Yeah, this ROS2 it's still super new and it's still under heavy development. Yes, so in ROS2 you are going to see still performance issues. You are going to find many bugs and things like that because it's still under heavy development. Yes, so you guys need to take this into account when working with ROS2. Yes, you cannot compare out of the box ROS1 in ROS2 because it's not the same. ROS1 it's something new which is under development still, and ROS1 it's something which has been already super tested and it has many years of development behind it. Yeah. Okay, I can see here loading, ready, loading. I'm at the same point as you. Loaded. It takes like forever for loading. Well, maybe you are doing something wrong, Ahmed. It might take 1 minute, well, 2 minutes, maybe. I am expecting much more fine-tuning on Cartographer in its parameters. Yeah, in Cartographer, you are going to see that we can tune some parameters. We are not going to go too deep into that because that would take much time, but we are going to see some parameters where you can modify them and tune them, etc. Loaded, ready to start. Please throw some light on fine-tuning cartographer on corner rotates in navigation. Fine-tuning cartographer on corner rotates in navigation. Okay, well, we are going to be seeing some parameters, but anyways, after this live class, you are going to get the code, so you can keep practicing and doing things there. So don't worry. Ready to go. Loaded. Finally. Okay, excellent. So we should be at this point now. Then in previous live classes, we weren't still working with simulations, I think. I think not. We were doing some practice with ROS2 commands, with nodes, publishers, subscribers, etc. But we weren't still working with simulations. So today we are going to start working with a simulation. Yeah? So, first of all, well, some basic requirements here about Linux and Python. Yeah, let's go for it. So, generate a map in ROS2. Why we want to generate a map in ROS2? Well, maps, if you have some background in ROS1 and you have worked with mobile robots in ROS1, you probably already know about the importance of a map in ROS, of creating a map or of having a map for autonomous navigation. Yeah. So nowadays we as humans, if we get, for instance, if we go to a new city to do some tourism and we get lost in that new city, what we would do would be to open Google Maps and see where we are and how we can reach our hotel or something like that. Yes. Well, Google Maps doesn't exist for robots yet, but robots use their own maps in order to localize themselves, in order to know the environment they are in. Yes. Then these maps can be already provided by us. If we have them, we can already provide that map to the robot. But if we don't have it, which is usually the case, we are going to have to generate this map. And we are going to generate this map by doing a mapping session. Yes, this is known as mapping in ROS and in robotics. Yeah? And basically a map, for a robot, a map is an occupancy grid map. What does this mean? Basically, this means that the map, this is going to be clearer in a moment when we start generating the map, but basically this means that a map is divided in cells, let's say. Yes, it's all divided in different cells. And each cell has a specific value associated to that cell. And that value can be, for instance, can mean that that specific cell is an obstacle, or that specific cell is free space, so that the robot can go there freely, or also it can mean that it's unknown space. Yeah, so the robot doesn't know what there is in that cell. Yeah, so basically this is how a robot will read a map and will understand a map. It's an occupancy grid map. Yeah, it's maps which are divided in cells, and each cell has a specific value which is represented also in a color. Yes, we are going to see all this in a moment, but for now let's just start the simulation. So in order to start our simulation, what we are going to do here is to open a new shell by coming here to the Tools menu and open a new shell. Yep. And then what we are going to do is to execute these commands we have here. Yes, so the first one would be to source our ROS2 version, which in this case it's Eloquent. We are working with ROS2 Eloquent. So opt ROS Eloquent setup.bash. There we go. Next thing is going to be to source our workspace, the workspace where we have our simulation. Yes, so source, well, let me copy just this command, copy and paste it. There we go. Source simulation workspace install setup bash. Yes, so this basically, let me open here very quick an IDE to show very quickly this. So here, as you can see in the IDE, we can see all the workspaces we have here generated. Then here we have one which is the simulation workspace. And inside this workspace, in the SRC folder, we have all the packages which we are going to use for launching our simulation of the robot. In this case, it's a Turtlebot 3 robot. Yeah, so that's why I need to source this workspace here. Yep, then finally, once I am at this point, I can come here and execute. Can come here and execute this command, which is the ROS2 launch command, which is the one that is going to actually start the Gazebo simulation. So let me execute this command here and wait until everything loads. There it is starting. All right. There we have our Gazebo window. It's updating here with the simulation, which I am loading, which I am starting here in this shell. Yes, so I can see here everything is white. Let me do a refresh so that the renders get corrected and I can visualize everything properly. There we go. All right, so here, as you can see, we have our simulation loaded. In this case, this is the environment we are going to be working on. Yes, it's like a building here with different rooms, etc. And here, close to the entrance, we have our Turtlebot 3 robot. In this case, this is the waffle version, the waffle model. Yes, here we have it. Here you can see the Turtlebot 3 robot. So once you execute your simulation, you should see the same as I am seeing here. Yes, you should see this environment. Let me dismiss here. You should see this environment here with the Turtlebot 3 robot that has spawned here outside this environment. Yep. So far so good, guys. Everybody is at the same point as I am. Let me see how you guys are doing. Launch error caught exception when trying to load file of format pi. Turtlebot 3 model. Okay. ROS distro was set to melodic before. Please make sure that the environment does not mix. Yeah, don't worry about that message. That's just a warning, dummy. Caught exception in launch. See debug for traceback. Caught exception when trying to load file of format pi. Turtlebot 3 model. Same error. Same error. Alright, so this is strange. The source simulation is not included on the project. So you don't have this command here, guys. This source of the simulation workspace. This command here. So you have to execute this command, this first source, and then this one, and the source of the simulation workspace here. And then you can launch the command, yes? So is the... Turtlebot loaded, says engineering nation. So for engineering nation, it has worked. I don't have textures in Gazebo. Okay, if you see everything white here in Gazebo, just click on the refresh button, which is going to render everything again, and you're going to be able to see it properly. Yes, click here, in this button here, which is going to reload everything as I am doing here, and then your textures should show up properly. Yes, but what I am concerned right now is this error that you are getting of the Turtlebot model, whatever. So guys, what has happened here? My project has closed. Alright, this is super strange. What has just happened here to me? Let me go back to my projects list. Okay, I don't know what happened here, but I'm going to restart everything again. Alright, so let me open this again. Super strange, this what happened to me right now. Okay, let me go back to the chat and see. I had to execute the launch twice. The first one stopped and waited forever, says Gabor. Copy it from the screen. I can type in the shell. Okay, that's I have an error and don't load Gazebo. It has reloaded with textures. Only the Turtlebot appears to be white after reloading. Yeah, the Turtlebot is normal to be white. I also have it white, so don't worry. Let me switch here to my face meanwhile this loads. Okay, it's reloaded only. Yeah, so if you have the Turtlebot white, that's normal. Yeah, don't worry about that. Gloria is also having this Turtlebot 3 model. This Turtlebot 3 model error. Yeah, this Somorita is saying you may be experiencing low performance from our remote computer. It happens due to the high usage of CPU RAM. Yes, don't worry. That's a message that appears because we are using free instances which don't have much power. So if you get that message, just click on the dismiss button and keep working, don't worry. Okay, so I also don't have the right PDF open. Where do I find it? What do you mean by the PDF, dummy? The right PDF? Okay, so let me... I am opening again my project because I don't know why it just closed unexpectedly. So I am going to redo everything again and let's see if I find your error. So the PDF, that's the Jupyter Notebook, dummy. I'm going to show you now how to open it. It should open by default, but... Yeah, I understand now. He means the notebook. The notebook, it's a Jupyter Notebook, and you can open it by clicking on the Tools button, and then clicking on Jupyter, I think it is. Yeah, Tools Jupyter Notebook. Yeah, that's it. Then let me review this. So caught exception in launch. See debug for traceback. Caught exception when trying to load file of format by Turtlebot 3 _ model. Okay, that's super strange, honestly. Yes, the notebook to open, it's the default IPy notebook. Okay, I can see that message from Felipe, getting a syntax error. Okay, let's see if my project loads. I think I'm getting some connection issues here. Okay, there we go. So let me switch right now to my screen. All right, guys. So first of all, let's go by parts. Yes. So here I have my notebook with the commands. Yes. So this, in case I close this, I can come here to Tools and select here the Jupyter Notebook, and this is going to open my notebook again with all the instructions and everything. Yeah. There we go. See? Then now let me open a shell here and let me try to reproduce your error, guys. So if I launch this directly, for instance, what happens? Okay, no, this is not the error then. So if I source this and then I run my command here, it's working properly. I don't see that message anywhere. So yeah, so I'm getting the textures problem here, but I refresh and then everything shows properly. And except the robot, which still shows here in, well, here it's not even showing properly, the robot, for some reason. So let me refresh this one more time. Yeah, it was still loading the robot. Yeah, it is still loading here. All right, so let me see, guys. Where Jürgen says everything works fine, must be local issues. Well, if Jürgen, if it were only one person saying this error, maybe it's local issues, but there are several people with the same issue. My stuff is working normally. Do I need to refresh Gazebo window? Well, in my case, yeah, here I can see the message here of the CPU RAM usage is too high. So just click on dismiss. So when I started the simulation, my textures weren't showing properly. They were showing in white. So that's why I just refreshed this so that my textures get reloaded and I can see everything properly. Yes? You see, now I can see everything properly. Yeah, so guys, you have to make sure that you are in this project, yes? The project is named life class number 92. Yeah? Life class number 92 mapping in ROS. If you are in other project, these commands are not going to work. So you need to be in this project, a specific project, yes? Then the steps to follow are these ones. So source this, and then execute this command. You can do Control C, Control V. You can copy paste directly, as you have seen. I just copy pasted the commands. So I have tried to execute this without the sources, but I wasn't either getting your error. So I don't know about this error that you are getting, guys. I don't know how you are there. Working, says Sarah Marullo now. So guys, the ones that you were getting the errors, one thing that you can try, okay, let me show you one thing that you can try. So stop everything, Okay, I'm going to stop everything here. If you have it working, don't stop it, please. I'm just going to stop it to start again. Then, if I try to execute this one more time, this is going to fail. Like this. Yes? So, exception unable to start server, but this is a different error. Then, in order to fix this, what I need to do is the following. Is a ps faux. I need to find the gz server process with this command here, ps faux grep. Let me copy and paste it to the chat. Then I kill this process. I need to get the PID of this process, which is 3551 in this case. It's this number here. This is the PID of the process. Then I kill this process. And then you are going to see that your simulation, well, in your case, if you don't have it, you are not going to see anything. In my case, you have seen that my simulation dies. I don't have now anymore the GS server process. And now I can restart this. This is going to restart my simulation normally. See? All right. Okay, so let me know really quick in the chat, guys. How many of you are okay, and how many of you have errors? Let me know real quick in the chat, so that I can know the current status. If everything is working normally, write okay. And if you are having this error where you can't start the simulation, put error or something like that, okay? So that I can know the current status of all of you guys. Okay, error, okay. Is an occupancy grid map a 2D map? What about 3D map? Yes, an occupancy grid map is a 2D map. Zach. For 3D map, well, I think in cartographer you can also create a 3D map, if I'm not wrong. But we are going to be working with a 2D map. Okay, I'm okay, error, okay. Error. Okay, error, okay, error. Okay, so we have too many errors. I don't want to continue because we have too many people with this error. I really don't know what is going on. How can I try to reproduce this? Let me try to debug this a little bit. This is a ROS1 command. Yeah, it doesn't make sense. Okay, all of you guys, do one thing. The ones which are getting the error, come to the simulation workspace and execute this command, colcon build. Yes, so I'm going to paste it here. Yes, so here in the simulation workspace folder, execute colcon build. Yes? Then when this command finishes, this is going to compile. Yeah, the colcon build command is used in ROS2 for compiling. Yeah? Then as you can see, this has compiled all my packages there. Then once this finishes compiling, execute the source command. So source of the install folder and setup.bash. Yes? So you come to this folder, simulation workspace. You execute colcon build. When this finishes, you do a source of the install folder and the setup.bash file, like this. Yes? And then after this, you try again the command. Yes? The command is this one. Copy it properly, please, guys. So ROS2 launch turtlebot3 underscore gazebo turtlebot3 underscore house dot launch dot py. Yes? So I hope you are not doing anything like this. No. Yes? Oh yeah, I have now the error for the GC server, so I'm going to kill the GC server. There we go. Bounce. There we go. Let me see what you get from the colcon build command. Still same error. Okay. I have no idea of what's going on then. I have no idea of what's going on. Okay, so I think the best thing it's going to be to continue with the live class and well, at least explain what I was supposed to explain. And you can, for now, the ones who are getting this error, this super weird error, just listen and watch to what I'm doing, and maybe later, if you reopen the ROS yet is going to work. Maybe it's something temporary. This is super strange. So what I would suggest to do is I keep doing the live class. I keep explaining everything, and then when I finish, as always, this is going to be published as a regular video. So you are going to be able to revisualize the video at any time. Yeah. And then we are going to try to fix this issue of the strange ROSject later. Yes. What do you think, guys, about this? So I keep doing the live class, and then this is going to be recorded, and this is going to be there for always as a video. And then at some point we are going to be able to solve this strange error you are getting, guys. So you will be able to do the live class anyways. Yes. Yes, I'll just watch. Thanks for trying to help us. Okay. Yeah, sounds good. We'll watch. Okay, so let's do this, guys. I'm going to keep going, and we will figure out later what's wrong with your. Well, let me do one thing very quick. Okay. So I'm going to write here to my colleagues so that meanwhile I'm doing the live class, they maybe can check your instances and see what's going on. Okay, I have contacted my colleagues to see if they can check this strange issue. So, okay, I'm going to keep going, guys. So, very quick, because it's already super late. Then, yeah, okay, so I have here my simulation loaded, as you can see, guys. And then what I'm going to do now is to start generating the map, yes? So, for this, what I'm going to do is to open a new shell here. And I'm going to start the cartographer node, yeah? So, I'm going to copy this command here. Oop. There we go. I'm going to source one more time my simulation workspace. Setup.bash, there we go. And I'm going to execute this command. Yeah, so basically this is another launch file which is going to start two things. Basically, it's going to start a cartographer node and it's going to start an ROS2 node. Yes, so that I can properly visualize my mapping session. Yeah, makes sense. So now I can open here my graphical tools. Let me move them to a different here window. And you guys should be able to see something like this. Yes, you are going to see something like this in RVs, here with the robot, and here some laser detections, yes? So if you see this, it's working properly. Yes, so now, once this is loaded, what we are going to do is to start moving and teleoperating our robot. Yes, so we have our cartographer node loaded. We can see here that it's starting to generate the map. If I remove or activate this, you can see the map appears and disappears. Yes, so this it's working properly, apparently. So what I'm going to do now is to yet open another shell here. Let me place it somewhere here. So I'm going to source one more time my simulation workspace, install setup.bash. And I'm going to now execute this third command, which is the Turtlebot 3 teleop package and the teleop keyboard node. Yeah, so this basically is a program for ROS2 which is going to allow us to control the robot from the keyboard using the AWSD typical keys. Yes, you can see it here, the indications. So A is going to be for rotating left, D is going to be for rotating right, W it's going to be to move forward, X it's going to be for moving backwards, and S it's going to be to stop the robot. Yes? So now I can come here and start with these keyboard keys moving the robot. So let me get a bit closer here, and I'm going to start here pressing these keys and applying these velocities, and you're going to see I'm going to increase here the linear velocity, and you can see there how the robot starts moving forward. Yeah, can you see there in the simulation? So my robot is starting here to move forward. Yeah, then I can also with the D apply some angular velocity, then the robot starts turning, as you can see here. Yes, this can be a little bit tricky to control at the beginning. Just try to move it the best you can. I already have some practice with this, so I can move it more or less quickly. But it's something you need to get used to. Yes. So what I'm going to do is to basically place it, move it inside this building. You can see now that I'm rotating to the left so that I start entering here this building. Let me do here an emergency stop to avoid crashing. Then let me rotate a little bit more here and start here moving forward. Let me visualize properly this. So basically what I want to do is to put it there inside some of these rooms. Yep. Okay, too much rotation there. Okay, let me start moving it forward. All right. It's even a little bit tricky for me, yeah, to control this teleoperation program. All right, there I am turning. Good. So let me go inside the right room, for instance. Let me cancel it now, the angular velocity. There we go, I'm getting here inside this room. All right, so I think I'm going to stop it here, enough. Okay, so I'm going to stop now the robot, there we go. Yes, so with all this, I should see now here, you can see that this has started building the map. Yes, this is not very correct right now. But I should start, well, here it's starting to build it a little bit more. However, there are some issues in the laser. Anyways, I'm going to stop it right here. And here at this point, what I should do is to start moving through all the buildings so that it properly detects itself where it is and it keeps generating the map. Yes, but this would take us forever. So what I'm going to do right now is to stop here and assume that I have done the full mapping of the building. And in that case, what I would do right now is to save here with this command the map. So I'm going to come here right now and execute this command here. Let me do it right now. So okay, here I think I don't have the here I'm getting an error. Why? Because I don't have the map folder generated here. So let me come here very quickly to my IDE and I'm going to generate this maps folder. So basically here what I'm telling, I'm executing this nav2 map server package and the map saver node, which is used for saving a generated map, and I'm telling him to save it here in the ROS2 workspace source folder maps folder and with the name map. However, this maps folder I don't have it created. That's why I am getting that error. You can see here inside the SRC folder I don't have this maps folder. So I need to generate it, I need to create it. Let me do it right now. New folder, maps, there we go. There we go. Okay, so now I have generated this, now I have generated this maps folder and now I should be able to save the map properly. So let me execute one more time this command. See, so now map saver succeeded. Then at this point, what I have is, if I come here to my maps folder in the IDE, I am going to see I have two new files, map.pgm and map.yam. Yes? So when I save a map, these two files are generated. The YAM file, it contains some metadata about this package. Yes? So where is the image, the model, resolution of the map, the origin of the map, some thresholds, values here, yes? So this is some metadata related to the map. However, here, this PGM file, it's the one that currently contains the map, yes? But this is a PGM file. So in order to visualize it, I'm going to need to download it and open it here in my local computer in order to visualize it properly. Yes, I'm going to open it right now. In fact, I don't have any application to open it. Okay, that's because it's a PGM, it's a strange format, so it's just a strange format. So let me see if I can open here, open it with Evans. Maps, map.pgm. I'm not sure if this is going to work. I don't think so. Yeah, I cannot open, I don't have support for the PGM format. Okay, so in my case, I cannot open it. This is not my normal computer, and here I don't have any tool to visualize a PGM file. Maybe, let me see what, if I have something, okay, where do I have it? Map. Okay, here it is. I really don't have any tool. No, I don't have. No, it's not going to work. Okay guys, so unfortunately here in this computer I cannot visualize the PGM file, but hopefully you can. So in your case, if you have some image visualizer which has support for PGM files, if you download this to your local computer and open it, you are going to be able to visualize the map that you have saved. Yes? In case this is a complete map, you would see something similar to this, an image similar to this. Yes? This is the map image which is generated inside the map PGM file. Yes? Then the gray space here represents space which is unknown for the robot. The robot doesn't know what there is here. Yes? Then the white space represents space which is free. It's completely free. So this is space where there is no obstacles. So the robot can move without problems through the white space. And finally, the black cells, the black color here, indicates cells which have obstacles. Yeah? So the robot cannot move through these black cells because they represent obstacles. Yes? This is the meaning of this map and this color distribution. Yeah? So let me know in the chat, guys, have you been able to visualize this map in your computers? Because here in my computer I didn't have support. Okay, I am starting to get now all the messages. I can see that Miguel here is helping us with this strange error. Have you guys been able to visualize this PGM file in your computer? Or not? Yes, my map is open, but doesn't seem correct at all, says Mikael. Yes, well, probably mine neither, because here, as you can see, I have started the map. It started properly, but here it went wrong. Probably this is something related to the cartographer parameters, which we are going to see right now, which we would need to fine-tune in order to improve this. But yeah, so the idea is this one. Yes, once you finish the mapping session, you are going to be able to save the map with this command, which is going to generate these two files, the YAM file and the PGM file. Yes, and the PGM file is going to contain actually the information of the cells and the information which really matters, which is if the space is free, if the space is occupied, or if the space is unknown. Yes? Then let's keep going a little bit, guys. So yeah, so basically this is all this process is called SLAM, which it means simultaneous localization and mapping. So this is the process of generating a map, a live map, while the robot knows at each time where it is. Yes? So this is basically the SLAM problem, which is a typical problem in robotics. And there are many algorithms which can solve this SLAM problem. In ROS1 there are many ways in how to do it. The most common one in ROS1 is the gmapping node. However, here we are using the cartographer package. Yes, we are using the cartographer node. Cartographer basically it's a SLAM algorithm, a SLAM system, which has been developed by Google. And this cartographer ROS is basically just a ROS wrapper for being able to use this cartographer in ROS. Yeah, so you can get more information here about cartographer, which is a Google open source project. Yeah, and as well from the cartographer ROS package, which basically it's a wrapper for being able to use cartographer in ROS. Yes. Then, as we can see here, cartographer has many parameters which we can tune. Yes, we are not going to enter into all of them because there are too many, and we don't have all that time, unfortunately. Maybe in other classes we can go more specific in how to fine-tune parameters for cartographer. It would be a very interesting class, I think, indeed. But however, here you have all the most of the parameters, or the most important ones, and what they mean. And these parameters, they are configured. This is different from ROS1 because they are configured in a Lua configuration file. Yeah, so in ROS1, parameters usually are configured in YAML files. Yes, in files like this one we have here. In ROS1, usually we work with this kind of parameter files. However, here, for the cartographer, we are going to be working with a Lua configuration file. What is a Lua configuration file? Well, let me show it to you. It's just a configuration file with a different format. So, if we come here to the simulation workspace in our IDE, let me make this bigger. There we go. We can open the Turtlebot 3 package. Let me close this, which is taking a space. And here we are going to find the Turtlebot 3 cartographer package. There we have it. Then if I open this, I'm going to find my launch file. Here, the one that I have started. Let me open it to review it later, indeed. And I'm going to find a configuration folder here, which contains this Turtlebot 3 LDS to the .lua file. Yes, then if I open this file, I'm going to find here all the parameters being set in this file. Yes, you have them here, all of them. Then here is where you are going to be able to change and fine-tune these parameters. Yeah, so here we have, for instance, the frame for the map, the frame for the odometry, the frame as well for the IMU link. Here we have some parameters as well related to the laser, the minimum range, the maximum range, more here number of laser scans. In this case we have one, but we could have more than one laser source. It would be this. In that case we would need to tune this parameter here, the multi-echo laser scans. For instance, there are some lasers which provide more than one detection in case they find glasses, for instance, windows, or this kind of stuff. So yeah, basically in this Lua file is where you are going to be able to fine-tune all the parameters for your mapping session. Yeah. Then yeah, here you have all the parameters divided by the filter ones, the laser parameters, the frame parameters, etc. Yeah. So I really encourage you and suggest you to have a look at this and try to modify these parameters in order to improve the mapping session, because as you can see here, it's not very good, the mapping session at this point. Yeah. So it started good, but it went wrong at the end. Then yeah, so here we have a launch file, a simplified launch file for the cartographer, for launching the cartographer node. So the one we have used here, it's a bit more complex. This is the one we have used right now, where we have as you can see, it's a bit more complex. We have many parameters being set here and loaded, but at the end, what matters here is this. So here we have the simplified launch file for starting the cartographer. So basically what we are doing here is to start here from the cartographer ROS package, the cartographer node. Yes? Then here we are specifying the configuration file, which is inside the config folder. In this case, we have here this tb3carto.lua parameters file. Yeah? And then what we are also starting from the cartographer ROS package, here it's the occupancy grid node. So basically what we are starting here in this simplified one, it's the cartographer node, which is the cartographer program, which contains the algorithm and everything with all the parameters that we are providing, and then the occupancy grid node. This node basically what it's going to do is to get the map that is being generated here from the cartographer node and convert it into a occupancy grid map, which is basically this that we have explained at the beginning, that divides the map in cells and assigns a specific value to each cell. And this value represents something, represents free space, represents occupied space, represents unknown space, etc. Yeah? So basically these are the simplified launch file for the cartographer. Yes? The one we are using here, let me show it real quick. We have here, for instance, the cartographer node. We have it here in this section here. But then we have also many parameters many arguments, which are being loaded here and here. We have also here a node for RVs, which is automatically starting RVs, as we have been able to see in the graphical tools, yeah. All right, and finally, last thing I wanted to talk about is the transforms, yes. So in mapping, in SLAM, transforms are very important. Why? Well, because as you can see here in our robot, let me get closer to it. And there we go. So here in our Tattlebot 3 robot, we have a laser, yes, which is here. This thing here at the top of the robot, this is the laser, yes? Then the map, basically it's generated from laser readings, yes? Then it's very important to have the transform correctly set for our robot. Why? Because, let me show you here this small image, yeah? So here, this would be our robot, and this would be the laser, yes? Then, the readings of the obstacles, so this laser is going to be constantly sending beams, yes? And when this beam collides with an obstacle, with a wall, for instance, this beam is going to return, and this is going to tell the laser what is the distance from the wall, yes, from the wall to the laser. But for our robot, we are not interested in knowing the distance from the wall to the laser, but from the wall to the robot. Yes? Because the robot is the one that is going to collide with a wall or with anything. Yes? Then, in this case here we have the robot which is mounted here, almost here, but in our robot, for instance, we can see that the laser is mounted at the center of the robot. Yes? Then the distances measured by the laser are going to be in reference to the center of the robot. But we are not interested in that distance, but we are interested in the distance from the wall to the base of the robot, because this is what is going to collide with the obstacles. Yes? Makes sense? So in order to know the distance from the obstacles to the base of the robot, instead to the laser, for this what we are going to use are transforms, what we know as transforms. Yes? That is why it's so important to properly configure transforms for your robot in a mapping process or for performing SLAM in general. Yeah, so we can visualize this super easily, for instance, in RBs. Let me show you real quick. I'm going to stop all this right now. So let me open here an ROS2 session. No, this is wrong. Sorry. There we go. So here I'm going to open a naked ROS or a new ROS. Let me move it also to a new window here. And in this ROS, for instance, I'm going to be, well, I have an image here from the whoop, this has closed. These are some of the books, for instance, that ROS2 has. Well, all right, so there we go. Let me remove here the image and let me add a TF display right here. And here I have the transforms for my robot. Yes? So for instance, if I take out all of them here, I can see this is the link for the laser, which I have here, and this is going to be related to the base of the robot, which I have here. Yes? Then the relation between these two links, the base of the robot, the chassis of the robot, let's say, the base of the robot, and the laser, this relation is performed through transforms in ROS. Yes, that's why it's so important to bear in mind and to properly configure the transforms of your robot for performing SLAM. Yeah, and yeah, basically that would be all. So we had many problems today. I don't know how it is doing, how it is going. If Miguel was able to find something. And let me try to see here some questions we have here. Thank you, but it isn't, will take a long time to explain. You can Google it. I don't know what do you refer, Andrew, there? I guess some question that somebody has done there. I am not sure about the online tool. I work with real robots. Well, Dinesh is saying this, and that's a very good point. So simulations are created and generated in order to complement real robots. Yes. So when you work with real robots, you cannot test anything there, because there is a chance that while you are testing your stuff, you can break your robot, you can damage your robot. Yeah. So that's why it's so, in my opinion, it's much better to first work in a simulation of your robot, and then you can test your programs in the simulated environment, you can test whatever there, because if you break something, it doesn't matter, it's just a simulation, yes? Then when you have tested your programs, your algorithms, your whatever in your simulated robot, then you can move that to your real robot, yes? So in fact, here in the ROS Developers 2, you have a tool which allows you to connect to a real robot and to send your programs to the real robot, etc. Yes, but basically the simulation, in my opinion, it's excellent for testing before working with the real robot. Yes. I can see, okay, I can see here. So what happened with the error? Can somebody tell me? Did it get fix it or what happened? Well, I will talk with Miguel later, so it doesn't matter to see what was going there. Yes, exactly. Simulation is always better. I need your project to reproduce this because in my system it seems to work. Yeah, it's something super strange because for some people it was working, for some people it was not working. I don't know if maybe it's related to the region where you are. Could be. Anyways, I will investigate later. The live class is free and so is ROS. Yes. Yeah, Andrew says live class is free, but the lessons require monthly fee. The guy teaching us has to eat. Yeah, I like very much that comment, Andrew. Yeah, so all live classes are free and we have units which are free. We are constantly providing many free resources for ROS1, ROS2, Gazebo, for many things. Yeah. However, we have our academy, where we have all the complete courses and everything, which is it requires a payment, a subscription. Yeah. Can cartographer use point clouds from a camera instead of laser scan? Yes, I think that's possible, Zach. Well, in my personal experience, I'm not a super expert in cartographer because basically I haven't yet worked a lot in navigation in ROS2, almost just testing stuff. So I'm much more used to working with ROS1 and working with gemapping. So I don't know very well cartographer, but for what I have read and seen, I think it is possible to use a point cloud instead of a laser scan. And then you can convert in some way, let's say, this point cloud to a laser scan, which is used then by the algorithm to generate the map. But yes, I think it's possible. You can here in the notebook, guys, I have placed a couple of links where you can get more information about both the cartographer algorithm by Google here and the cartographer ROS package. Yes, here you can get much more information about many things. Yeah, so in case you want to learn more, you can have a look also at that documentation. Okay, guys, so I think I'm going to leave it here. I'm sorry for the problems, so I don't know really what happened. It was super strange. So for some people it was working properly, for some people it wasn't. It was like a 50-50% more or less. I don't know, we will try to investigate what happened there, because it's super strange. It hasn't happened in previous live classes, so I don't know what was going on there. So yeah, hopefully for next live class it's going to be much more smooth and not as interrupted and as problematic as this one. So sorry, guys. I hope at least you have been able to enjoy a little bit this live class and learn something new. And don't worry, because when this ends, you are going to be able to rewatch this video as many times as you want. And you're going to be able to test the project when we solve this problem. You're going to be able to test the project without problems. Yeah. So yeah, guys, thank you very much. I'm going to see you next week in live class number 93. Until then, as always, keep pushing your ROS learning. Stay safe. Keep yourself safe, stay home, don't go out if it's not strictly necessary, and take care, basically. So yeah, thank you very much, guys, and I will see you next week. Bye bye.